Alright, welcome gate members. Today we'll be looking at the motility of the GI tract. So this is the physiology of the movement of food from the mouth down to the anus and into the toilet or whatever. So first of all, we'll be looking at the diagram of the whole GI tract. You can see from the mouth to the esophagus and then the stomach and the small intestine, then the large intestine. So you can see those red dots. Those are the sphincters. They regulate the passage of food. And then we have two other structures here: the liver, the gallbladder, and the pancreas, making them three. Alright, so let's start from the mouth. So when food enters the mouth, there are a lot of physiology to consider. We have the mastication reflex, where the food is chewed and mixed with saliva. So in the mastication reflex, you basically be considering how the jaw opens and closes. Now, the opening and the closing of the jaw is done by four muscles. To close the jaw, we have the temporalis and the masseter, which I've highlighted here. And then to open the mouth, we have the lateral pterygoid and the digastrix. So these muscles are innervated, and based on their innervation, they help in opening and closing of the mouth, which brings about the mastication reflex. Now, we now go to the salivary glands. I said mastication is basically chewing, which mixes the food with saliva and turns it into bolus. So the salivary glands are sorry for that. The salivary gland are divided into two. We have the extrinsic and the intrinsic salivary glands. Now, the intrinsic salivary gland don't produce much saliva, while the extrinsic salivary gland produce 90% of saliva. These extrinsic salivary glands are the parotid glands, the sublingual glands, and the submandibular glands. And I showed their division here, so make sure you go through it. Now, in the production of all this saliva, the composition of saliva is water, inorganic constituents such as your electrolytes, then we have thiolin, glucose, uric acid, lysosome, protein, and many more. So, if you are to read on the digestion of carbohydrates, you will know that in the mouth, carbohydrate digestion starts with salivary amylase. So, as the chewing reflex occurs, there is a mixture of the food with saliva, and then digestion of carbohydrates occurs immediately. Now, after the mastication reflex, we also have the deglutition reflex. The deglutition reflex is basically the swallow reflex. That's how you swallow food. So when you chew to a point, you have to swallow the bolus. Now, this deglutition reflex is divided into three. We have the buccal stage, the pharyngeal stage, and then the esophageal stage. Getting to the esophageal stage, the food is already in the esophagus. Now, this is the esophagus. The esophagus is a tube that basically transfers the bolus from the mouth into the stomach. So we have the upper esophageal sphincter and the lower esophageal sphincter. These sphincters are there to regulate the going to regulate the pathway of food so that there won't be reflux. So that whenever the bolus crosses into your uh esophagus from here, it will not be able to go out anymore. So on getting here, we have basically one movement because the esophagus function is to transfer food from the mouth to the stomach. So there is only one movement here, which is peristalsis. Peristalsis is the series of contraction and relaxation in the muscles of the GI wall to facilitate the movement of the bolus. So we have types of peristalsis. We have primary peristalsis and we have secondary peristalsis. Primary peristalsis is the wave that comes from the oral cavity and pushes food directly into the stomach. Now, let's say this wave is not enough, the peristaltic wave is not enough, then we have the secondary peristalsis, which is another wave of peristalsis that occurs now in the esophagus to empty its content into the stomach. So there are two clinical significance we'll be considering here. One is achalasia. Now, in achalasia, the smooth muscles of the esophagus are not relaxing well, so they are not able to empty. So it is not able to empty its content very well into the stomach, which means that there are some food particles remaining here, and these food particles has to go somewhere. Sometimes they get pushed out into the lungs, or sometimes they are just there and then they start growing bacteria, which can cause a lot of problem. Then we have chalasia. Chalasia happens when your lower esophageal sphincter is having problem. So the lower esophageal sphincter is unable to contract appropriately. So there is a reflux of acid from the stomach into the esophagus, which can cause heartburn. So let's take a look uh, at the histology of the GI wall. So in almost every part of the GI wall, you see this type of structure. This type of arrangement. So we have the adventitia or serosa, we have the muscle layer, we have the submucosa, and the mucosa, which opens into the lumen of the GI system. Now, the adventitia is basically the outermost covering of the GI tube, because the GI tube is a long tube that extends from your mouth to the anus, and then it is divided into adventitia or serosa based on location. If it is inside the peritoneum, it is called serosa, or if it is outside the peritoneum and attached to other structures, it is called adventitia. The muscle layer now. The muscle layer contains the enteric plexus. You should know in the muscle layer we have three muscles, two longitudinal muscles and one circular muscles. So in between the second longitudinal muscle and the circular muscle, we have the enteric plexus. The enteric plexus is a motor network of nerves that are located on the walls of the GIT, and they regulate the contraction of muscles. In the submucosal plexus, we have in the submucosal layer rather, we have the mesenteric plexus. The mesenteric plexus is responsible for regulating secretions that goes into the lumen of the GI tract. And then we have the mucosa. The mucosa is basically the epithelial lining around the lumen. So that's for the histology of the GI tract. Now next we go to the stomach. So when your food moves from your mouth, from your esophagus, it drops into the stomach. And a little bit of anatomy here. This red uh, opening here is to show you the esophageal hiatus. The esophagus passes down, and as it is about to enter the stomach, it passes through a hole in the diaphragm, which is called the esophageal hiatus, before turning to the abdominal aorta, then before emptying into the stomach. Now, a little bit anatomy on the stomach. The stomach is divided into five. We have the cardia, which is very close to the esophagus. We have the fundus, we have the body, we have the antrum, and then we have the pylorus. And then you can see this pyloric sphincter. Now, there's a lot of work in the stomach, but there are three major movements. One is the mixing movement. Now, when food enters the stomach, it gets poured into hydrochloric acid, which is basically the gastric juice, and digestion starts occurring. Now, the stomach undergoes a series of contractions that is not peristalsis, because you can see apart from mixing movement, we also have peristalsis. So, this mixing movement is not peristalsis, is like segmentation, but it's not segmentation also, because segmentation is in the small intestine. Now, this mixing movement, just as the name sounds, is basically meant to mix the bolus with the gastric juice. So, after undergoing a lot of movement up and back and forth, the bolus starts dissolving and turning into what's called chyme. Now, at this stage, peristalsis occurs. And peristalsis is basically a series of relaxation and contraction that propels food forward. Now, when the food is propelled, let's say from here, and is propelled towards the pyloric sphincter, there is a phase of gastric motility, we will call that. You should see that in the phase of gastric motility, we have storage, and we also have mixing movement, and then we have grinding. Now, let me explain storage first, because all these things work almost at the same time. So we have to understand it by integrating it together. Let's come back to when the bolus enter the stomach. There is a reflex called the receptive relaxation reflex or the gastric distension reflex. This is basically the enlargement of the fundus and the upper part of the body. So they enlarge in this direction to accept more volume of food. So that's what we call receptive relaxation. So the size of your stomach doesn't stay constant. When there's more food, your stomach detects it by stretch receptors, and then it enlarges to accommodate more volume of food. Now, after storage, there's mixing movement. And then after the mixing movement, I told you we have what's called chyme. Now, not all the chyme at this stage is able to pass from the pylorus through the pyloric sphincter, because the pyloric sphincter only allows a certain size of particles to pass through. Now, the particles that have been grinded to that size are allowed to pass through, while the bigger particles are shoved back, and then they undergo another series of mixing movements, which is now called grinding, because they go back and forth now from the pyloric sphincter back into the body and into the antrum, where they are dissolved more. That's why it is now called grinding. And then when they are now to the size of about 2 micrometers or thereabout, they are now able to pass through the pyloric sphincter and then into the small intestine. That's why we now have gastric emptying. In fact, that's what gastric emptying is about. Now, the reflexes we have here, we have the vagal reflex. This is the regulation of the activities of the GIT through the vagus nerve, which is cranial nerve 10. And then we have the gastric distension reflex, which I've already explained. We have the peristaltic reflex, which is still peristalsis. We have the enterogastric reflex. The enterogastric reflex is between the small intestine and the stomach. So there is a period of time when there will be too much chyme going into the small intestine, and then there will be a stimulation or a signal sent to the stomach, which will increase the contraction of this pyloric sphincter now, so as to stop or so as to reduce the amount of chyme going into the stomach. Then we also have the gastrocolic and the gastroileal reflex. These reflex are basically reflecting in the large intestine and in the small intestine, but the signals are sent from the stomach. So you should know that the distension of the stomach will affect the small intestine and the large intestine respectively. We'll be looking at them in details when we get to the large intestine and the small intestine. So another movement type I've not touched here is the migratory motor complex. The migratory motor complex happens during the fasting state. That's after you've eaten for a long time. There is what we call the migratory motor complex. The migratory motor complex is a very strong peristaltic wave that empties everything in your stomach into the small intestine. So bacterial growth can still happen even with hydrochloric acid inside the stomach, and the body wants to avoid that. So it will want to empty everything in each section of the stomach, in each section of the GI tract into the next section, so that there won't be bacterial growth. So this MMC is basically doing a house cleaner job by ensuring everywhere is clean to avoid the bacterial growth. Isn't that wonderful? Um, Next up we have clinicals. So what's the clinical significance we can find here? One, we have gastroparesis. Gastroparesis is when there is delay in gastric emptying. So when there is too much chyme in the stomach, even when they are supposed to be able to pass through the pyloric sphincter, but they are still left in the stomach, it could lead to bloating and some other issues if it is not taken care of on time. And then we have pyloric stenosis. Pyloric stenosis is when the pyloric sphincter this time becomes tighter. So let's say there is an inflammation of the pyloric sphincter and it becomes bigger. It will block all the space that is in between, and that will stop every uh, every sizes of chyme from passing through. So when there is this inflammation, it can also lead back to gastroparesis. And in this situation, when it is diagnosed, you have to open the person up and then cut off some part of the pyloric sphincter so that the food particles can move. So from here, going back to gastric emptying, we will say the chyme empties into the duodenum or the small intestine generally. Now let's look at the small intestine. The small intestine, at this point, there is chyme that has been mixed with gastric juice. So what happens here is segmentation and peristalsis. In the small intestine, there's what we call bile secretion for fatty acid and acidic substances. Bile secretion comes from the gallbladder, the liver, and then we have pancreatic juice from the pancreas. We'll not be looking at that now, but let's just say everything has been mixed up and this is your, should I call it chyme? This is your food anyway. It has been digested to all of these points. During digestion and absorption, I'll be going on more details on how digestion is occurring, and then during gastric secretion, I'll make a video on that. I'll show you on the substances that are secreted in each section of the GI tract. But for now, let's stay on motility. So what are the movements we have in the small intestine? We have segmentation. So this is like segmentation proper, not just mixing movements. and then we have peristalsis. Okay, segmentation is basically named so because of the anatomy of the small intestine. If you've seen the small intestine before, you will notice they are having something like segments like this. These segments. So the bolus is now divided, maybe cut into little tiny pieces and put into each segment, just as I've done here. And then there is a lot of back and forth movement. This back and forth movement might sound like mixing movement, but I already told you the anatomy of the small intestine is what actually makes it proper segmentation. Now, there will be a kind of mixture between these two, and a kind of mixture between these two, and a kind of mixture between these two, and a kind of mixture between these two. So this makes sure that number one, the bile secretions and every other secretion are mixing well with the food molecule so that there is optimal digestion. The small intestine is responsible for the most part of absorption. So we want to make sure every part of this food particle is digested so that it can be absorbed and moved into the cells. Alright, so after this segmentation movement, we also have peristalsis. When there is enough segmentation and then we need to go down to the next stage, there is a peristaltic wave that contracts and relaxes this time around and pushes the food particles forward and downward into the large intestine. So here we have the gastroileal reflex again. The gastroileal reflex, as I've said earlier, comes from the distension of the stomach. So the distension of the stomach is the enlargement of the stomach. When the stomach grows bigger or when it extends, the small intestine receives signals from the stretch receptors. So when they receive these signals, they know they know that food is coming. So that's just what the signal is about. They feel food is coming. Let's put it like that. And then they start emptying their contents into the large intestine rapidly. So that's the gastroileal reflex. It's just like the preparation of the small intestine to receive more substances, more time from the stomach. And then we have the ileocecal sphincter here. I was not able to show it in the diagram, so I just cut it out here. The ileocecal sphincter regulates what's going out from the jejunum, no, the ileum rather, from the ileum. I hope I'm not making a mistake. Ileum or jejunum into the cecum. So from the terminal ileum into the cecum, there is a sphincter that regulates what's going out and what's not. So during this gastroileal reflex, there will be relaxation of this ileocecal sphincter to allow more particles to go through in time. So that's that. And then I think the last thing here is to talk about the clinical significance of this stage physiologically. So number one, we have the paralytic ileus. During paralytic ileus, there is no movement. Yes. Instead of all this movement we talk about, there is a paralysis of the nerves that stimulate all this movement. So it is just there. Your food particles are just there. There are no segmentation and there's no peristalsis. And the next thing that will occur in this type of situation is that the food will start witnessing bacterial outgrowth, and then there is a lot of trouble to come with that because digestion and absorption will also take place. Yes. Then we have the intestinal obstruction. Intestinal obstruction, maybe let's say there is a lot of gallstones in the small intestine, and maybe there is uh, a granuloma somewhere, there's an inflammation somewhere, and then the food particles are unable to pass as they ought to, and then maybe they start to back up. When they start to back up, that's what we call intestinal obstruction. So there is no adequate flow, there's no adequate movement of the food particles from the small intestine into the large intestine. And then we also have the irritable bowel syndrome. The irritable bowel syndrome is more pronounced in the large intestine. I mean, the physiology, the pathophysiology is more relevant in the large intestine, which we will go into now. Now, the large intestine. The major absorption takes place in the small intestine, and in the large intestine, we have the absorption of water and electrolytes. So, the large intestine is relatively larger than the small intestine. That's why it is called the large. That's why it is called the large intestine. I think that's repetitive. So, what are the movements we find in the large intestine? Number one, we find ostration. So, ostration is basically the same thing as segmentation, actually. But according to what I told you earlier, I told you segmentation is due to the anatomy of the small intestine, and this ostration I will also say is due to the anatomy of the large intestine. So, the large intestine has these big sac-like structures, which we call ostra. These big sac-like structures, which we call ostra, is what is in the large intestine. So compared to the small intestine, these ostras are bigger. That's why it is called ostra. Because when you translate ostra, you will see it means bag-like. So it is like a bag. So there's a kind of mixing movement also in these ostras that makes it to be called ostration. And then we also have peristaltic movement. That is the proportion of food into your towards your anus or towards your rectum now. So we have the second, we have the ascending colon, we have the transverse colon, and then we have the descending colon before come to your sigmoid colon, and then your rectum, and then your anus. So the movement of this food particle throughout all these segments is done by peristaltic movement. And the last one we have here, we have the mass movement. The mass movement is like the peristaltic movement, but this one is a little bit more bigger. That's why it is called mass. All these things are just English. So the mass movement is basically a large peristaltic movement. So compared to the normal peristaltic movement, there is a bigger movement involved. There's a bigger proportion involved in the large intestine. Maybe from the ascending colon to the transverse colon, there is something like a hill to be surmounted. So this mass movement helps in pushing the food up against gravity and into the transverse colon. So you should understand it as that. Alright, we have reflexes, we have the defecation reflex. So you should know what this should actually mean by now. The defecation reflex is a series of uh nervous reflex that actually brings you the sense to go to toilet. So it is divided into two. We have the intrinsic and the parasympathetic. The intrinsic reflex is the one that happens on its own. So there is a weak wave that alerts you that you have to go to toilet, but you are able to hold it back because the waves are very weak. And then we have the parasympathetic, which is more voluntary. Now you're in the toilet and then you want to do your stuff. So you initiate that defecation reflex voluntarily. And if it is parasympathetic, you know it is related to the vagus nerve. So that's that about the defecation reflex. The last thing we have to consider here is the clinicals. We have H-sprung disease and we have paralytic ileus. This paralytic ileus is more common in the small intestine, and then we have the IBS, which is also the irritable bowel syndrome. I told you the irritable bowel syndrome is much more pronounced in the large intestine, right? So the types of irritable bowel syndrome we have constipation and diarrhea. So during constipation, there is slow movement in the large intestine. So there is excessive absorption of water, making it difficult for you to pass through. So that's it for constipation. Then we have diarrhea when there is quick movement, a lot more faster movement of the food particles from the small intestine to the large intestine and towards your rectum. So the large intestine is unable to absorb even the normal amount of water. So that's why there is a lot of uh water in your stool when you have diarrhea, because the water is unable to get absorbed. I added this just for the fun of it. So it is in the toilet, in your stuff. And guys, that brings us to the end of this class. I hope you learned a lot. And yeah, I'm just starting up this. And I really hope to impact a lot of students from this. So if you want to support us, you can support us by liking this video, dropping down a comment, sharing to your friends, save it, and then follow up so that when we drop new content, you can also follow along. Alright, guys, welcome to the guild.